Today we're taking a look at section 3.3 on the conditional and circuits. First, we'll take a look at the conditional statement. The conditional statement is made up of the phrase if, then. And in symbols, we have an arrow that is pointing to the right. So if P, then Q would be symbolized with the P, the arrow pointing to the right, and then the Q. So in number 1, my example, if it rains, then I will take my umbrella, is an example of an if-then statement. If you do your homework, then you will pass the quiz, is also an example of a conditional statement. Now, in the conditional statement, if P, then Q, P is called the antecedent and Q is called the consequent. So if we look at the first example, it rains, is the antecedent. You do your homework in the second one is the antecedent. Now let's look at the consequent. The consequent is the then part, leaving off the word then. So I will take my umbrella. You will pass the quiz. Those are the consequents in those particular statements. Now, suppose I make the statement to you, and I want you to understand I am not making this statement to you, but suppose that I did. If you pass the quiz on Thursday, then you won't have to take the final exam. And again, note I am not making this statement. Let's suppose I did make this statement. Let's determine when I have lied or made a false statement to you. And I don't know why this changes when I switch over to the journal, but it does. Alright. So, if you pass the quiz on Thursday, then you won't have to take the final exam. That's what we're looking at. Let me highlight that so I can find it when I'm talking about it. Okay. Alright. Suppose that you pass the quiz and I don't make you take the final exam. Did I tell the truth or did I lie? Of course, I told the truth. Okay. Now, suppose you do pass the quiz, but I decide to make you take the exam. So the second part is false. Have I lied to you? You pass the quiz and I make you take the final. Then I lied to you. I made a false statement. Now, suppose you don't pass the quiz and I don't make you take the final exam. So the first part is false. You don't pass the quiz and I don't make you take the final exam. Did I tell a lie? Well, actually, I did not say what I would do in the event that you did not pass the quiz. So you have to make the assumption, you know, in the justice system where it's supposedly a person is innocent until proven guilty. Okay, I'm honest until proven a liar. And only in this second case so far have you proven me to be a liar. Now, if you don't pass the quiz and I do make you take the exam, again, I didn't say what I would do if you didn't pass the quiz. So you have to assume that I'm being truthful. So the only time that a conditional statement is, let me see if I can get my green to highlight here, is false is in the event that the antecedent is true and the consequent is false. It's the only time the conditional statement will be false. And remember that statements that are always true are called tautologies. Conditional statements that are tautologies are called implications. So we have another special term for a tautology that is a conditional statement. Now, I have a statement here that we're going to construct a truth table for. And it looks like it needs a P, a Q. Looks like I'm going to need a not P. If not P, then Q. I'll go ahead and put that in there. Then I need a not Q. And finally, I need a conjunction of the last two columns. last two statements. Okay, we only have two different statements, so we only need 4 rows. So 2 true and 2 false under P, and then alternating under Q. Okay, negating P, we'll get false, false, true, true. Okay, so now we have, and let me change to yellow, this column and this column. So here we have our antecedent and our consequent. So we're going if false then true would be true. If false then false would be true. If true then true would be true. If true then false would be false. Now we want to negate the column Q, which is right here. So that would be false, true, false, true. Now we're forming the conjunction. Let me get the blue, if I can get this to open up. Conjunction of these last two columns, so we're joining them with an and. True and false would be false. True and true would be true. True and false would be false. False and true would be false. Is it tautology? No. It can't be an implication because we would have to have if then here for it to be a conditional statement, as well as having it to be a tautology. And let me fix these. Like I said, I'm not sure why it does this, because there's plenty of room there for it to spread out. Okay, now how do we negate the conditional statement? Well, let's look at our 4 cases. Okay, if true then true is true. If true then false, that's the one case that's false. If false then true is true. If false then false is true. So if we're negating that, what we need is we need a false, true, false, false. Okay, now it turns out the negation of the conditional statement, and this is a little strange. This is something you're going to want to make note of. It turns out to be a conjunction. So I'm going to go ahead and fill in this column, negating Q. Now what I want to look at is the column for P. Let me get my column for P and the column for not Q. So I'm joining those with an and. True and false would be false. True and true would be true. False and false would be false. False and true would be true. Okay, let me change my color if I can get yellow here. Alright, here's the truth table for the negation of the conditional. Notice I need a false, true, false, false. Notice what I have here. Whoops, that one should be false. And I think I wrote true when it should have been a false. Let's double check. False and true would be false. Okay, so we can see that the negation of if P then Q So what we do in order to negate, for example, the statement, if it rains, then I will take my umbrella, we negate it by saying it rains, so we keep that the same, and not Q. So in this case, I don't take my umbrella. I don't take my umbrella. So that's the way we negate a conditional. Alright, so very important. Let's see if I can get it. Highlight that in pink. Purpley pink. Okay. Now, we can also write a conditional statement in the or form. If it rains, then we go to the museum. we could rewrite as it doesn't rain, or we go to the museum. So if it rains, then we go to the museum is equivalent to it doesn't rain, or we go to the museum. So we can rewrite that as an or statement. All cats chase mice, we can change to an if-then. If it is a cat, then it chases mice. And then to rewrite it as an or statement, it isn't a cat, or it chases mice. Okay, now we found an application for logic. It's used very often in libraries where you're doing searches on using search engines to find research information. Also, we have circuitry as another application of logic. And it turns out Claude Shannon showed how logic could be used to design electrical circuits. And what he showed was that AND results in a series circuit. So if you have this would be an example of circuits in a series. We have to have both of them working in order for the power to go through it. Or results in a parallel circuit. Here we only need one of the two, so it's P or Q. Those are what we call parallel circuits, and these are what we call circuits that are in a series. And there are some examples in your textbook you'll want to take a look at on pages 126 and 127 to see some more examples of circuits. So next thing you need to do is watch the sample problems for section 3.3.